welcome to the Sci-AI podcast. This is episode number 13. Today, I have invited Prashant Sharma. He works at Hitachi Central Research Labs in Japan, working on Explainable AI. Alongside that, he is currently doing NLP research. He has graduated from IIT Bombay in India with a master's focused on machine intelligence. Let's bring him onto the podcast now and start asking him some really cool questions on AI. Hi, Prashant. How are you doing?
Yeah, great. Thank you, Vivek.
Great. Thank you for coming onto the podcast. So my first question is, what is explainability in artificial intelligence? How is it different from the black box approach in designing an artificial intelligence machine?
Yeah, good question to start off with. So let's first understand what do we mean when we say that we have a black box system. So when a system is receiving some input and producing some output, and we know we can base our decision based on the output, but we don't have an underlying understanding of how it is giving us that output, then we say that the system is black box. Now, for maybe most part, having that abstraction layer works for us. So you are at a traffic signal, you see a green, red light. More often than not, you trust that system. You need not understand how it is working. You just need to see the light and make your decision that whether to stop or go forward. So when it comes to explainable AI, why we need that. So because AI right now, which is impenetrating all aspects of our lives, is also part of some crucial aspects where sensitive decisions are to be made. So let's say your doctor is taking a help of an AI system to recommend you some medicines. Now, definitely in such a scenario, what you would like to have as a patient is for that system to have some accountability in terms of its recommendation of those medicines. And that is where this whole concepts of having a need to trust these AI systems, which are ever becoming part of our digital fabric, which is very much ingrained into our social fabric as well as society. This need of explainable AI came up especially it has been focused in the last decade after the rise of deep learning methods. So that is why the need is there. Now, how do we approach to solve it? So I will give you a very simple example. So let's say first let's try to understand how a human expert would do it. So let's say again you go to a doctor. Okay, let's not take your example. Let's say a person goes to a doctor and the doctor sees the person's X-ray report and says that, oh, I can see that you have signs of tuberculosis. Now that is definitely a scary thing for the person, and the person ends up asking, doctor, what is wrong with my chest? Can you talk me through what is wrong? Considering the person being reasonably educated to understand what the doctor will try to say. And the doctor could point out to the X-ray and say that, look, on the left side of this chest X-ray, you can see these anomalies, which are a result of a tuberculosis infection. And by visually looking at that X-ray, the person, and with the instruction of the doctor itself, the person will trust what the doctor is trying to say. Now, again, now there is a lot of talk definitely of AI in healthcare and doctor replacing radiologist with ever great accuracy. The idea is that the AI making this prediction of a binary prediction that you give it an X-ray or an MRI and it making just a prediction that, oh, you have this disease or not, but not telling you why it is making that decision. So how do we incorporate that element into our system? Currently, how it is being approached is that instead of just giving an output that whether the person has a disease or not, the AI system is also made to give an output as to which part of an X-ray it is looking at and try to highlight those parts. so that whoever is looking at that X-ray, a user could be a doctor or even the patient themselves, they can look at those highlighted part. These are just some weights which are attached to the image pixels, and look at this part. Okay, fine, these highlighted sections look weird, so maybe this could be the reason why I'm having such an issue. So the idea is not to just predict a binary value which just says that a person has something or not, but also in some form try to predict the underlying explanation which can assist either the doctor or the patient to see or to trust the result of the AI system. So that is how the explainability is being approached currently, but it is a very primitive way to approach explainability just by looking at these gradients. So currently, definitely it being a fairly recent research interest to the community, the focus is to uncover the underlying causal relationship. By that I mean looking at the medical report. If someone is by looking at the medical report for let's say a hospital is predicting that the person will have a heart attack or not with certain probability. Now just this decision that the person will have a heart attack or not, you cannot offload it to a AI system. So along with that, it is not even you also cannot design such gradients to or weights to attach to just particular bits. So what we need from AI system is also output to the user or the stakeholders, in this case doctors as well as patients, the underlying relationship as to these were the medical parameters and such as such relationship. Because of such and such relationship that has been discovered between these parameters, the system is predicting that the patient is likely to have a heart attack in this year. So
amazing.
Going from a surface level weighted understanding taken as a primitive explanation, right now the focus is to uncover this causal relationship. It's still currently a challenge. There are various ways in which we are going about it, but yeah, that is where we are going with respect to trying to uncover more of these black box AI systems. Yeah.
Right. Fantastic.
I hope that helps you. Yeah.
Yes. It really helped answer the question of why explainability is so important. So it's not just fixing the problem, but it's more about how I did it, what I did it, so that you can use that data later on in your diagnosis for other patients. Is that right?
Yeah. So actually, one thing is that under the umbrella of solving the problem, the umbrella itself is becoming a little big. I mean, like 10 years ago, we were not even sure that whether we will be able to create a system which can predict whether someone is having, let's say, there is a case of diabetic retinopathy. So people with diabetes, they are having problem in their eyes. So with their eye scans, trying to predict that the diabetic patient is going to have a trouble seeing years down the road, or just based on those scans, it is a doctor's job. Now, I mean, just 10 years ago, we could not be confident that we can build such systems. Now we can, thanks to the data as well as, the modern CNN networks that we have. So our concept of solving the problem was that to at least to have a system which can say that whether the person is having a eye issue or not. Again, trying to predict in binary categories. But now once the AI systems are capable to do it, our understanding of solving the problem now is, expanded. And what we want to say is that, like a doctor is saying that this is why you are having eye trouble, we want the machines also to be able to say that. So so basically what I mean is our understanding of solving the problem is increasing, now including a component to trust the AI. One component of trusting the AI is explainability. There are other pillars as well. So privacy is one of the biggest pillar for trustworthy AI. I mean, especially we're talking about medical case. So privacy of your medical records become a huge deal. Like imagine an AI system out there in the cloud, okay, and for predicting the decision, your data has to leave the hospital servers and to go to the cloud, okay, which is located at a different location. So in between, because of some attacks, your data could be captured, and again, your medical records could be released. And that is why there is interesting research which has come out of University of Oxford. I mean, the lead research, I am particularly aware of a researcher named Andrew Trask. He's a leader of Open Mind community. So basically trying to build platforms, because conceptually the mathematics exist, that this question of how do you train AI models on encrypted data. So what I mean to say is explanations is one segment, privacy is one segment, safety, AI safety is another segment. So there are a couple of 3-4 segments which researchers are actively working on for us to make the AI trustworthy, so that we don't just have a black box AI, we have the decision as well as we have different aspects which can enable us to trust this AI system. One of it, that is explanation. Another is handling of private data. So privacy preserving AI safety, and some more. So AI ethics is another pillar that comes to my mind. So all these pillars combined is now that we have seen the AI success for the past decade, for it to see it penetrate effectively into our lives, we need these pillars covered. And that is why, researchers are focusing on these pillars. So, yeah.
Right. Fantastic explanation. Great. So you've not just touched on the explainability part of it, but also the other pillars that are going together with it, so that it is not just helping us solve a particular problem, but also securing, because it's in the cloud, and also making sure that, it is one of the trustworthy things that humans will use in the future. Fantastic. Does our brain work in the way like an algorithm is being coded through DNAs into us, and then we can understand patterns just like we train a neural network? Or how do you see it?
Yeah, so interesting question actually. So one thing which comes to my mind is that, my understanding of human mind is that even we as humans have not fully understood how our minds work. Okay, we have some understanding in terms of how we make decisions, and we have some understanding when we are not being rational. So when we are, let's say, emotional, people make decisions when they are in emotional state and not very rational. And although one could argue that the feeling emotional, feeling a particular aspect of emotion is also rooted into one aspect of intelligence, which people could formulate arguing about intuition. But not going there, because you brought up our mind's algorithm being encoded into our DNA. The idea is that this point assumes that all the aspects of our mind, however it behaves, is physically encoded into our physical brain.
Right.
And yes, there are theorists in the world who talk like that our consciousness is a result of our physical brain. Mm-hmm. But then there are also theorists which talk about that it is not so. So when we divide our consciousness into it being conscious or subconscious, in those two halves, we say that some are voluntary actions which affects our conscious mind, and there are some involuntary actions which is subconsciously controlled. Like you're breathing right now, your heart is pumping, you are not consciously controlling it, but it is happening. So yes, some form of it, especially with respect to physical aspects, we can trace it back to our DNA coding. But so those aspects you can write algorithm for it, and you can even train models for it, for that matter, because those physical phenomena have been discovered and understood by us. Right. But when we talk about some aspects which we ourselves as humans are not aware of, little tricky. So that comes under the discovery part, that we ourselves don't understand how our brains work. So how can we even think about discovering that phenomena? Because we ourselves are not even aware of all those aspects. So how do we do that? Definitely when we discover such aspects, we can perform tests, we can then trace back the relationship between our DNA and that phenomena. And then because right now we can process our genome using neural networks, then we can build such models. But it is a spectrum, that's all I want to say. And in that spectrum, we have whatever we have understood, yes, we can model it using different models, and yes, we can use neural networks there. But a large chunk which we are still trying to discover regarding our own minds, we are yet to discover those, and even to discover those using our modern methodologies, we need to have some understanding of the phenomena to define that objective function, so to speak, so that when to stop, when to say that, okay, fine, this is the right solution that we are looking for. So that is my understanding of how our brains work and what part of it can be modeled using, let's say, modern neural network. Yeah.
Fantastic. Great answer. Okay, great. So my next question to you is how important it is to keep AI ethics in mind when building the right kind of AI. You have already used this as one of the pillars when you were talking about how the brain and the DNA coding works and explainability. But let me ask you then about AI ethics. And can you talk also about safety engineering process when building the right kind of AI? Because that's, I think, one of the most primary things that we should focus on when we're building these strong things which can topple our intelligence one day.
Both AI ethics and AI safety tie back into our goal of having trustable AI systems. So first, let's tackle the first part. When you say that your question was that how important is to have AI ethics in mind when building any AI system for that matter.
Correct.
So, before trying to think about having AI ethics, let's fall back to this question that why we as humans need ethical codes for functioning in the society, right? And what we will understand is that ethics are mostly related, moral values, etc., are related when we consider that some right or wrong is to happen. So, for example, things like stealing, ethical laws, moral laws around stealing, okay? Maybe one person harming the another person, okay? Or maybe even having moral laws about lying or spreading misinformation. So the idea is that all of these factors contribute to the instability of the society functioning. So we as humans place these laws, and it has been part of various religions, such that instability is not, achieved as a society. Now, when we are talking about ethics for AI system, what we need to understand is that because more and more what decisions we as humans are making in our lives is being offloaded to these AI systems. And when done so, the idea that the AI system will optimize for a solution where it can ignore those same moral and ethical laws that we as humans placed ourselves for the smooth functioning of society, we can experience chaos. So, the thing about, let's say, spreading misinformation, or even, let's say, there are various shows which depict that there is an AI system which is predicting that XYZ is likely to be a criminal based on its profile. So definitely in this sensitive manner, it is very, very imperative. I mean, we have this, I may be wrong about the, exact legal term, but the idea about that innocent until proven guilty, right? So the onus falls onto us to prove the guilt. So, I mean, tomorrow if an AI system is trying to do that, I mean, we better have some ethical laws in place so that instability of that system, the AI system does not contribute to the instability of the system. So do we need it? Yes, definitely. How do we integrate it is, again, as I talked about previously, yes, we have some understanding. So we can integrate those ethical points into an AI system, but still a long way to go so that, everything can work hand in hand. So AI ethics with explainability with other pillars as well.
Yes.
First part, I think I answered regarding AI ethics. The another part was about, AI safety
engineering. Yep.
Yeah. So again, the same thing. Think about any human marvel that we have done. Like simple things like we humans, let's say, created knives to hunt. Okay, I'm back in the day.
Yeah.
So I mean, we have these rules around our houses that knives will be, far away from the reach of children's, right? I mean, they won't be lying around the kids of the house. So these safety rules, although we implicitly understand now, has been, developed evolutionary, how we as society have evolved. Again, why? Because by not following those safety guidelines, what it will contribute to is some form of chaos in the human society. Again, kids harming just because knives were lying around the house and the elders of the house did not care about it. So will contribute to that chaos in that family or subsequently tribes, etc. So similarly, when we are talking about AI systems, it is imperative that AI system which is deployed for an aircraft and onto an aircraft, the right processes are present such that in case of any safety trade-off that AI system has to make, it ends up aligning with, again, given the ethical guidelines, aligning to the right decision, then to someone to just, let's say, optimize for that reward function that has been fixed for the AI system to make a decision on. So yeah, those are my thoughts around about AI safety processes.
If artificial general intelligence, as it is usually said, is far in the future, does it mean that not enough research will take place in the coming few decades in general intelligence? Because why would companies waste time in building something that engineers are not interested in working on currently? And not just this, when not enough infrastructure and platform is available to build the general intelligence, why would, any researcher or any company start building it?
Again, we'll take these questions into parts because I believe there are 2-3 sub questions that you have asked.
Yeah.
So let's take the first part when you say that whether artificial, if it is to be assumed that achieving artificial general intelligence is far away in terms of time scales when we will achieve that, then does it mean that not enough research is going to take place in the coming few decades? So for that part, what we need to ask ourselves is that, again, see, this part of your question talks about a goal, which is to achieve AGI and how we are going to get there, correct?
Yes.
Now, when we ask ourselves this question, that what is AGI? Why do we need to ask that question? Because how do we know that we have achieved AGI if we don't have an understanding of what AGI will look like to us? Okay.
Right.
So for most part, let's look at it this way. Currently, what we see is this. You train a CNN to do visual tasks, and you mostly, use recurrent neural networks and its various forms to do sequential tasks, which are very prominent in natural language processing. There are two kinds of model that you're trying to use. One for, taking care of visual task, or one for taking care of, let's say your spoken task. Okay, you're speaking or listening something. And there you're using AI systems, different AI systems trained on different data set to make use of, you are using different AI systems for visual task as well as your language task, either spoken or whatever you heard or whatever you're writing, to solve different kind of problems in isolation. That's how we have been traditionally dealing with, because we as humans did not have this general sense of what a single model or even a group of models working together would look like, which can solve, let's say, a visual task, a auditory task, or a spoken task, or a written task. Now, what is happening of late, there is a research going around on multimodal learning. So having a single big neural model combined with a CNN and an RNN, I mean, an interesting work of which was done by Andrei Karpathy, who during his PhD days at Stanford, when he created this single network combined with CNN and RNN to produce what is called as image captioning. So you give an image and you're also having some textual output. CNN is convolutional neural network. RNN is so convolution, just operation, after the name of the operation that we are performing, which is convolution operation, and recurrent because of its recurrent nature. Combining these two kinds of architecture, his PhD work was focused on generating image captions, giving a raw input. So this example I gave to just illustrate that of late, our understanding of combining these systems is at a very basic stage, that we are still trying to figure out that if let's say we are talking right now, okay, and we are to, although it is a podcast, so it is very simple for training an AI to detect our faces and also transcribe our speech, whatever we are saying. But let's say we would have been out in the wild. I am walking in some farm and you are in a street surrounded by a lot of people. And then let's say you want to train a system which can block out all the noises in the surrounding, maybe detect all the objects around you so that while walking, it can give you safety alerts as well. All the while maybe detecting for faces, etc. To do all of these things by various combination of different modern architectures, it is still a challenging task. We have theoretical underpinnings in the name of, multitask learning or meta learning. But the point is that now, why we are talking about this? Because that is the level we are at. And when we talk about AGI, so imagine having a combination of these networks on a machine, like how we have our brain, which is when connected to our eyes or ears or faculty of throat and mouth through which we can speak, it can function very well. So let's say we set that to be our goal. But even then we are very far away. So but the question which you asked, that if it is far away, is there going to be no research? So that's why I illustrated all these points, that far away, but yes, we are taking some steps to combine these various models, the multi-model learning that we are doing, whatever we are doing, trying to do with multitask learning, to reach a point where we can have a system it could be what we see right now by combining all these different kinds of architectures, or doing some ingenuity with respect to how we are learning the data distribution, etc. The research is ongoing, and we are progressing in that direction only. But yes, with respect to what do we mean by AGI, do we mean that if we achieve the working intelligence level of a normal human adult brain, if that is our goal, yes, we are going in that direction. So we know that AI system can detect objects at various scales much better than we humans can, because of rise in deep computer vision research that we saw. And yes, same movement came for language itself. You might have heard about GPT-2 by OpenAI. So yeah, so what I mean is that achieving human intelligence, if that is our goal, yes, we are there. So it is not so that research is becoming stagnant there. Research is ever there. It is just that either because of lack of data, which is very prominent today in AI research, or lack of our understanding of these phenomena, we are not able to design these networks either for the discovery of these mappings to make that next big leap. So research will not stop towards our goal to have a AGI system. Now, arguing about a AGI system, how it will affect our future, is a separate topic, but research continues in that direction only. A company, bunch of people come together to achieve a vision, which is usually directed by the founders of those companies, because people who join these companies believe in that vision, and that is why they join the company in the first place. That is the whole deal, at least in the startup, when the company is in the startup stage.
Correct.
The engineers are the one who are joining the vision or subscribing to the vision of the company, not the other way around. What we are proving in research versus what the industry is trying to implement is ever decreasing. And that is why what you are seeing is that right now papers comes out in a top AI conference, and within 1 month you will see implementation on GitHub. So that's where we are at. Gone are the days when there was a paper released, 5 years ago, and people are still developing the solution practically. So with this gap ever decreasing, as soon as we are making those AI leaps towards this goal of having an AGI system, you will have opportunities for engineers, even the companies, to make it into production, as well as make it available for the engineers so that they can work on such opportunities. We do see that, engineers are the people who will build these systems based on which, let's say, the next frontiers of research could be explored, right? I mean, we needed to perform those Higgs boson experiments. We needed that engineering to be done, so that we can perform the experiment to observe the data and then check our assumptions. Mm-hmm. So similarly, when research, as I just mentioned, that as soon as something is proven in research, right now, the gap is ever decreasing. So because of this decreased gap between theory and practice, the people in the company as well as the engineers are going to build such systems. And when they build such system, they will build the platforms and infrastructure which is necessary to perform next set of experiments, to maybe push our boundaries to take the next leap bound towards the AGI step.
So yeah, you touched the right points actually. But the reason why I asked about the infrastructure and the platform is, so for example, if we go 30 years or 40 years back when there was no internet, if an entrepreneur thought about building a web page or something, it is not possible because there's no internet available to do it, right? I mean, you cannot have people do the same tasks through a landline phone or a phone, right? So whenever an infrastructure is provided, it's something that the researchers or the entrepreneurs can work on. One more example to this could be SpaceX, Virgin Galactic, Blue Origin. All of these are infrastructure providers for us to go into space. Without them, you can be sure that entrepreneurs and private companies or private researchers will not be interested in going to space with the help of NASA or European space agencies or Indian space agencies. You would need that strong infrastructure provided to you in order to go there by anybody. So that was the kind of idea for asking you about the sort of infrastructure provided to the AGI researchers in order to carry out. So for example, do we have enough neurobiologists working on something like the philosophical terms, something like free will and determinism, in order to understand our brains and how we function? And then we can replicate that kind of thing to a general intelligence machine. And so, yeah, that was the idea behind this question.
Yeah. So, fair points actually, Vivek. Thank you for your thoughts there.
Sure.
So, yeah, I mean, when you say that whether the platforms and infrastructure at present are there for the kind of collaboration that you're talking about between interdisciplinary people, bringing neurobiologists on, maybe philosophers even, and bringing AI researchers. So that is where this talk about having a platform which can have, let's say, privacy, safety, ethics, etc. All of this is to be built, and that is the primary of that being, I guess, privacy research. So this is the example that I saw in one of the lectures by Andrew Trask, who again is a researcher out of University of Oxford working on privacy preserving AI. What he said is that if right now someone wants to work on Alzheimer's disease, okay, he or she would like to have that data set which is maybe stored behind some various rules, etc., various inefficient systems on some servers or computers across the globe. If we can build a system where the people who have the data regarding the Alzheimer's are not at risk of losing the data, or they lose the ownership of the data, and until we build such a platform, we cannot perform that Alzheimer's research. Okay. And that is the whole idea with having a privacy preserving platform, which can have a data which can be encrypted, also have a model whose weights can be encrypted, but still the computation, the training part for this training, if I want to train my model on this encrypted data, that can take place. I do understand with that angle, but yes, so is the work going on? Yes, definitely. The work with respect to engineers, what I try to mean was engineers are always, there to quickly, I should say, scale wise, timeline wise, quickly put it into production. And even I would say that there was one comment, I guess, in Professor Jan LeCun's talk, when he believed that invention precedes this discovery. That I believe, I might be paraphrasing. He was trying to argue that first telescope was invented, and through observing through the telescope, then we try to, make our headways into, let's say, astrophysics. My point is, invention, which engineers and practitioners do, they are ahead, so they are not far behind. That's what I meant. So any new discovery, etc., will be motivated, but more often than not, the platform infrastructure, people are already there to build it. It is that on algorithmic side, whether our understanding has increased to utilize that platform or infrastructure to take the next jump in, towards the AGI.
Great. So my next question to you, Prashant, is should there be a kill switch in ensuring that whenever AI becomes like extremely dangerous to our civilization, it can be shut down? What is your opinion on it?
Again, interesting and nice question. So actually, the concepts of kill switch, we don't need a kill switch only when we see AI system destroying the world or spreading mayhem all around, which will be a good thing for a movie. Even with the simplest of the things where we are taking the help of AI, we need a kill switch. We definitely need a kill switch. And ever increasing, see, this ties back to all the points that we discussed about explainability, ethics, and AI safety, all of those things. When you are trying to use an AI, which is in a scenario of a hospital, AI assisted diagnostics, you definitely need a kill switch, because tomorrow if you see that some erroneous update has been pushed to the model and it is making weird predictions, you definitely need a kill switch. I would even go on to say that you don't even need to go to the hospital. Let's say there is a AI assisted thermostat in your apartment. You need a kill switch for it. With AI or no AI, you need a mechanism to shut down that main board which cuts out the electricity on all of your devices. We as humans integrate technology into our own lives. It is a double-edged sword. I mean, let's take electricity for example. We know it's a double-edged sword. So we definitely need a kill switch, because we are playing with a fire and we might learn a few tricks to control that fire, but we might also don't know whether that fire can go out of hand. So kill switch a must, even definitely for the sensitive cases, but even for the simplest of the cases, you need that kill switch, because currently we are not at the stage where we can say that from the explainable angle or ethics angle, I trust this AI system as I would trust, let's say, a sensible human being. As of now, maybe in some time we'll have so. Then definitely we need that kill switch so that, cut off being dependent on that decision which is driving our lives. So yeah.
Great answer. Can AI predict the next pandemic? What kind of models and use cases are needed in the AI system to achieve this feat?
I think a lot of responsibility has been pushed onto, I guess, AI researchers to, because all of us agree that the pandemic has been a surprise throughout the globe.
Right.
So yeah, but okay, let's discuss the scenarios there. So, okay, let's take the simplest of the cases. Whatever might be the case, the virus being natural born or maybe engineered in a lab or whatever be the case, the idea is that...
I actually heard a YouTube video of Bill Gates in 2015 where he predicted that the next pandemic is coming and it will go out of our hands. And it was a TED talk that he gave. And I still remember how vividly he mentioned that and how clear and crisp that communication was, and we still could not actually stop it. So yeah, it was known even before it came, but yeah, sorry, I'm digressing. Please go ahead.
No, actually, okay, yeah. Thank you for bringing out that point. I have not watched that particular TED talk, but yes, I have heard about such talks by Bill Gates. Right. So see, one thing we need to understand is this: whether something bad will happen you can say with certainty, Murphy's law. If anything is
Right.
is to go wrong, it will go wrong.
Right.
You always have that. But the nature of that wrongness is what we are concerned about. So, see, here's the deal. Currently, by analyzing the healthcare system in whatever country you are in, you can say that, okay, fine, based on the history of the viruses that we have seen so far, the effect of the viruses has been increasing at this particular rate. So maybe with this cycle, 10 years down the line, 20 years down the line, we do predict that such an outbreak will be there. But, and we have a sense of that it will affect X number of people, but currently our infrastructure does not support that. That we understand. But one thing we need to understand is that because we don't know anything about the nature of the virus itself, then even if, what do you tell your researchers to work on to develop the vaccination if you don't even have a single case based on which they can analyze the genome and maybe create your vaccinations, right? So what I mean by that is, based on the inefficiency of system, you can predict that something bad will happen and we won't be able to handle it. Right now, let's say climate crisis is one such thing, that definitely something is about to go wrong based on our current system, which we are trying to update. But do we have a complete sense of understanding that what will be the nature of that catastrophe? At climate level, we keep hearing about there are floods. I mean, in fact, already we are experiencing torrential rains in many parts of the world at odd months in the year. So what I'm trying to hint at is that for this nature of uncertainty, we have some understanding. So we do say that, okay, fine, if it is to go bad, the nature will be such that there will be floods everywhere. Drought at most places will happen, because we have that understanding of the nature of the issue that we will face. But with virus, it is a different ball game. You can say that whether the infrastructure is there or not, so that the amount of time it takes for researchers to develop the vaccination, let's say there is a small population of 1,000 people. I mean, I'm taking a very simplistic example for a country. I mean, it is probably an island, and there is a healthcare facility there. One can say that, okay, fine, there is, in the next healthcare virus outbreak, the current infrastructure won't support the healthcare of the people. So how one can be prepared there is to have a healthcare system so that in worst case, if all the 1,000 people needs to stay in isolation, provided with, let's say, food, etc., for them to survive for, let's say, 6 months or 1 year. Why? Because those 6 months and 1 year will be the time taken by the researchers to observe those virus samples and then prepare a vaccination so that they can be injected. So yes, this augmented infrastructure we can have or think of in terms of preparation of the virus, but nature of the virus itself is something that we are at shock at. I mean, this virus itself, like COVID, made everyone talk. I mean, the top researchers across the world try to understand its nature and to see what is this whole deal about. Right. And yes, slowly coming to a conclusion based on which, again, vaccination were made available, etc. But it was a long battle and a larger battle than what historically we have seen. So will there be a battle? Yes. But battle preparation is what we can focus on. The nature of the battle, especially at virus scale, as per my understanding goes, I might be wrong there. It is a tricky slope. So if we as humans don't have an understanding, so this ties to this part that if we as humans, so remember, everything is boiling down to this fact that human researchers are taking 6 months to 1 year of time to develop that vaccination, by analyzing the genomes of the virus, etc. But let's say we can build an AI system which can speed up this process. On the first part, I talked about how focus on the infrastructure if everything is relying on our own human understanding of the virus. But yes, with the help of AI system, we can have such AI system which can speed up this process of, let's say, discovery or analysis of virus genomes. So let's say instead of 6 months to 1 year, it is taking 3 weeks or even, 3 weeks, 1 week, whatever. I don't know when in future we will have it. But the idea is that AI system helping us analyze the genome so that the development of the vaccination could be fast. A future of AI that I see is is to work on those algorithmic aspects there, so that basically we can have those solutions much more faster than when only a group of human researchers are working on it. So it will be mostly like AI assisted tackling of these crises, but infrastructure is also a bigger component there. I mean, no matter what smart AI you have to give the solution, but even if basic things like people could not be quarantined in properly in that thousand, in the example that I gave of 1,000 people living on a particular geographical space of this world, how do we, what do you even do with that solution that you can achieve with AI? So both of this will go hand in hand. That's what I can say there. That, but with respect to prediction of the phenomenon, we definitely can say that something will go wrong with the nature of the phenomena. A lot needs still to be done. I mean, there was one research out of, you might have heard about AlphaFold, which was related to the problem of protein folding. So basically trying to predict 3D structure of proteins which govern various aspects of our biological functions. Now, if they are very proteins are very, as far as our understanding goes, they are very fundamental to our processes. So if right now, research wise, we are at that place, who knows, maybe in 10 years, we are at that stage where we can say that based on the analyzing the configuration of the genomes, we can predict such and such permutations will be flawed. And that is why, or even with respect to discovering a new configuration which we initially assumed to be good, we can take help of an AI to make the analysis faster, so that whatever structure we want to analyze or even create to tackle the virus, we can do it in a faster fashion. So yeah, that's how I think in this context.
As per my limited knowledge in this, I see it like this, that you've beautifully worded the fact that, it can speed up the process. But I was like, there is a reason why it is called an artificial intelligence machine, right? So when it comes to intelligence, it means that it can do stuff or predict stuff based on our human anatomy, our cell structure, our proteins, and the red blood cells and our fighting power inside that can fight with these viruses. So it can predict those things better than humans. And if that is possible, that is going to be a mind-blowing thing going forward, because now we can, instead of relying on not just human intelligence, but also on another kind of intelligence which can do better calculations faster and predict new outcomes going forward.
Yeah, the AI in healthcare application that we see is just, let's say you show X-ray or retinopathic image to a AI, it tells you whether someone has a disease or not. But the Deepmind work, which worked on the protein folding problem, why it was such a big buzz in the community was because for the first time, at least in human history, the interdisciplinary team of researchers where trained researchers from biology department were there, and definitely AI researchers were there. They created a solution on which apparently traditional researchers who are not using AI were stuck on for quite some time now. So when you say that an AI system which is capable of making prediction on this level, that let's say it analyzes your DNA and just ahead of time predicts that, based on your permutation of DNA, let's say let's say you're living in a cold country, you suddenly go to a hot place in some desert for a vacation or so. And based on your configuration and your exposure to the environment, your body is not ready for it. So based on all of those parameters, it is able to predict that your body will adapt not very good with this environment, adjust to the surrounding in very mild configurations for some time before heading out. So but the point is that for this scenario to happen, this fundamental problem, as we see, definitely this AlphaFold success that we see is a big step towards that direction only. But still a lot needs to be done there. I mean, this is just one gem of a thing that has happened in this direction. But yes, full blown, whatever scenario you described, we will have that stage, and that combined with whatever Elon Musk is trying to do. Maybe I don't know how many people will insert the chips in the brain, but the idea that because we as humans are a little slow because of that system 1, system 2 theory that came out of, I'm forgetting, Daniel Kahneman. Yeah,
Right.
so who won the Nobel Prize for it. So basically having these two systems that we as humans do, one very fast, one slow. The idea that we have a fundamental bandwidth problem, and that is why we need a chip merged with our brain so that to solve that bandwidth issue. And then that with all the AI models that we are developing, we can make those calculations. And when something is merged to a human brain, reading the biomarkers, etc., or even estimating them becomes somewhat feasible. Then by just outside means, just instead of scanning a person, you can directly take data onto the surface of their body. From their body, from the nerve endings on their body. So crazily fascinating future, I must say, but a lot to be explored still. Yeah,
Absolutely. Yes, it is going to be a great future. Fantastic. What is neuromorphic computing? Can neurobiological structures be replicated to make a highly connected network like our brain?
Okay, yeah. So as far as my understanding of neuromorphic computing goes, see, as I said, in our attempt to create intelligence, quote unquote intelligence, where do we take reference from? I'm talking, let's say, just rewind back like 100, 200 years ago. You want to create such a machine which can work intelligently, but the definition of intelligence that you have is again humans around you. So you try to understand human brain, and now by understanding human brain, you're trying to replicate the concepts into a model.
Yes.
So there is a famous work in mammal, basically researching based on mammals, which was done by Hubel and Wiesel. It is a very popularly cited work in computer vision community. Basically, they did experiments with cats, and based on that, it was a study performed to analyze the visual system of cats, assuming that cats are similar to human babies. And they made some observation based on which, those observations were leveraged, that which is utilized right now into our having a hierarchical structure of the CNN. That initial layers will have lower level features, and then the deeper layer will have a higher features. So in the initial layers, you will detect the edges, corners, etc. But as you move deeper into the layers, the shape of the object, let's say you are trying to detect someone's face, the shape of the structure of the face emerges into the later layers. Based on some biological understanding, yes, some ideas were taken to configure the networks in a particular manner. And as far as that goes, my point is that although we give it a different name, that's how it has evolved. But so to answer the first part, and the second part of that, can these neurobiological structures be replicated to make a highly connected network like our brain? So coming to this part, what we need to understand is that in whatever limited sense, when humans, let's say, have analyzed our visual cortex or our auditory system, and maybe some insight that we try to leverage to configure our modern models, that is always possible. But yes, there are some, but one could argue that maybe the biological way in which it is happening is inefficient. But here, what we are trying to do with this electronics is much more efficient. We can talk like that. But yes, there are some aspects of our human brain which are very interesting to AI researchers. So for example, memory. The way human brain deals with memory is very fascinating. And right now, our AI systems, I should not just say AI systems, but whatever systems we have where we have tried to have like a digital memory. So even having hard disk RAM, and even having some state which is saved while training of a network, all of that is trying to leverage that memory concept, but that is very, very primitive. So in such a scenario, it depends on our own understanding. If our understanding of efficient utilization of memory in biological brains increases, then those techniques can be leveraged definitely while designing such models. So, I mean, and this is an active field as well. I mean, trying to leverage whatever studies happens with human brain and trying to see if that can give us some insight into our models. You know, I can think of actually very interesting application which happened in the lab I was associated with at IIT Bombay. So there's something called as I-mind hypothesis. So the idea is that, let's say, when you're reading a text, let's say either a newspaper or on your screen, when you're trying to read let's say a text which is full on your screen and trying to read a text which is, let's say, humorous, okay, versus a text which is somewhat tragic in nature. So just by tracking your eye movements, one can predict to a decent extent what kind of text you are trying to read. So a lot of this work was done in my lab by one of our senior researchers of our lab, Dr. Abhijit Mishra. He's right now in US working with Apple R&D. So he worked on this field of research is called as cognitive NLP. So based on your eye movements, how can you improve the sentiment analysis system, or even natural language generation, machine translation, or whatever. So yeah, so the point I was trying to make with this example is that an observation based on our own mind, that our eyes and our mind, the decisions our mind is making, is reflected or can be captured to a decent extent through our eye movements. And that is why even we as humans, when we are talking to someone, we can see that, oh, the person was happy during our conversation, or he is sad, all of that. Definitely there are other markers as well. For example, our cheeks, our smile, all of that. But just even by narrowly focusing on eyes as well, we are getting a lot of information. So that concept has been leveraged, and AI systems are being built using those leveraged concepts. So this was just one example to outline that fact, that as our own understanding of our functioning, our brain improves, yes, AI community is ever ready to include that insight if it is definitely helping us to achieve an efficient AI system. Yeah.
Fantastic. Great point. If AGI becomes exponentially strong in intelligence, which it will, how will we understand whether it is good for us or not? Why I say this to you is that they may have different goals than we have, for themselves. Why do we then need to build such a thing in the first place when we know that they can have a different goal, or they can be exponentially more intelligent than us? What do you think about it?
Yeah, so interesting question. When you say that if AGI is becoming sufficiently strong day by day, so how do we understand whether it is good for us or not? Exactly. So you cannot understand just based on its decision that, okay, fine, this decision is to be made, just that, and not giving you any reason, explanation around why the AI system is making that decision. And that is why those pillars of trustworthy AI that we talked about become that framework under which, if AI is operating, we prevent it from such an outcome where it is taking a decision which we cannot understand. Yeah. So because some form of that needs to be present for humans, basically humans should be in that loop of AI decision making. Otherwise, because again, AI is operating in our world, we need some, again, the kill switch question that we talked about. We need that way. How do we make the decision? Based on the level of trustworthiness which I can judge, or you can judge, with the AI system that you are interacting with. Or even, let's say, the government can judge when they are using AI system to maybe analyze some data which can assist some policies that they are going to deploy in their nation. So the idea that if it gets stronger, do we understand it? No. If we don't take care of these trustworthy AI aspects, we don't get to understand it. That is why the AI safety problem, AI alignment problem, trying to have ways in which we can establish trust with the AI system is ever important. Because in absence of this, we cannot do anything. Yes,
Right.
we can say that if it does something wrong, we will have a kill switch. But why have that first instance of having something wrong take place itself? If we can avoid that by having these frameworks in place. We cannot understand this until unless we have these frameworks at place. And as you rightly mentioned, that they, in the absence of these AI ethics, safety, alignment, and other aspects, whatever goals that they are optimizing for, we can, until unless a human is having some say in that goal, human by human, I mean our own ethical laws. If it can be integrated with those ethical laws, that we as a society, we will be devoid of the catastrophic outcomes. If not, those are very likely. Now, one might argue that maybe the set of rules that we have in our society are not optimal, so to say.
Yeah.
That some rules removed from there, some rules removed from there will have an efficient system, and that is all possible. So if it can be understood by us, because we as humans are the one who have brought down those rules, let's say in law or even moral codes, etc., etc. So we can use help of AI, but even there we need the transparency to work with that AI system, because again, the result of that AI system to delete certain rules or to add a new rule is something which is going to have massive ramifications. And that is why, again, in the framework of transparency, safety, and alignment through our own goals, until unless that happens, I can say that the AI community is pretty aware of this problem, and that is why the active research into this direction has already underway. So yeah, I mean, we cannot blindly rely. We need to work, and we are already working as whole, AI research community.
Since you're working in artificial intelligence at Hitachi in Japan, what kind of innovations or mind-blowing stuff that Japan is working on that you might know? Is it anywhere close to China's artificial intelligence adoption? What do you think about it?
Again, interesting question, because talking about AI at a national scale is a tall order. But
Right.
whatever data that I am aware of, so Japan has been very good with one aspect of AI, which is robotics, and that we have been hearing about since, again, as at least I was a kid, that Japan is very aggressive into robotics. Now, let me first answer this part of Japan's status as per my understanding goes with respect to AI adoption. There was one survey surprising that Japan is the leader in terms of AI adoption, ahead of the big names that we hear, US and China, which is surprising to hear, because you keep hearing this news from Google, Facebook, and even from China, Baidu, and I don't know, a bunch of other companies that are present there. So true. I mean, true that there are interesting and massive research budgets at national level for all of these companies, but Japan in itself is not far behind. I mean, in fact, some of the surveys report that it is actually leader on global scale in terms of AI adoption. Now, AI research, etc., people could argue that the number of research being published out of China is they publish the largest number of, let's say, papers in top AI conferences, and that is why that part is said that China is leading. Yes, they are leading in terms of research, no doubt about it. But when you're talking about integration to the actual system, the practical aspects that we are talking about, the point that you raised about infrastructure, I mean, no doubt that China also have invested heavily onto developing of their infrastructures in the past many decades, and that is why they are at a stage where if they have to deploy a AI solution, the infrastructures already exist, so they can do it. Definitely there is an ethical side to it. Like, we keep hearing about the massive surveillance which is happening it is happening in one form or the other, maybe in every nation, but more prominent we hear in China. So the idea that you're having interconnected CCTV networks across your nation, tomorrow you want to deploy an AI system, you could do that. But first have that infrastructure in place. And which is, again, all those CCTV camera are manufactured inside, let's say, China, not outside, right? So having this this infrastructure to make and produce the infrastructures on the top of which the AI systems can be deployed. China has been working at that, and Japan is no different. Japan, the way Japan has raised, it has the during and post-industrial revolution, it has come to a place where it invested in those primary manufacturing industries. That is why the network of homegrown Japanese companies, which are now global names, the infrastructure is always there, and the nature of Japan is such that they are early adopters to technology because of maybe earlier influence of robotics, because in one way or the other, Japan, let's say, knows that with respect to manpower, so to speak, offloading work to a lot more robots is much more beneficial. So in that way, Japan has been investing for a long time into robotics as well. So why? Again, because infrastructure is there. That is why Japan has been able to do it. And it is definitely not surprising to see that in adoption wise, they are at a position where they can adopt very quickly, and they are actually adopting very quickly. With respect to how far even different countries are with respect to China, as I said, one metric which comes out in news right now is AI research, which is definitely, they are doing a lot of research. Basically, a lot of manpower has been pushed towards AI. And definitely China by no means is very far behind implementation as well. But because again, it being a closed system, we don't know much about at what level things are happening. So comparing becomes a pretty tricky aspect. So yeah, I mean, definitely in some aspect, let's say even US is scared about how they deal with systems, right? So yeah, so because of that, comparison is tricky. But if we try to understand the underlying principle which will make a country thrive for AI adoption, that is definitely the presence of its manufacturing layer. Like if I talk about India, like my home country, and
I was actually about to ask you, and sorry to digress on this. What is your opinion on India then, AI adoption in India?
Yeah, so see, let's take a step back and see that, if we talk about the momentum of AI adoption, and we hear that in physics, we hear that it has two components, mass versus the vector for velocity. But let's say the model that we are trying to build to predict this AI adoption rate, let's say we're trying to do it. One component will be the agents which will allow the AI adoption to happen. So I talked about the physical layer, which is present in the form of manufacturing for, let's say, Japan or China or US or maybe some other countries. And I'm talking across sectors. So across sectors. So yeah, so it is not that one country is only industry largely dependent on oil production and not on, let's say, producing steel to build certain infrastructure. I'm talking across the board. So in that way, where India is lacking currently is that India does not have, India has some big names definitely for, steel, etc. Definitely a lot of big names are there. But across the board, if we see, we are way far behind in manufacturing. India has a lot of brain power software wise. Right now, Bangalore is said to be Silicon Valley of India. So, right from the days when India was looked as a call center of the world, now it is being looked at R&D center of the world by, all these big companies are opening their R&D center in India. So brain power is there. But when India is to build its own AI infrastructure, an infrastructure on which AI can be adopted, that is where we are lacking right now. Look at the amount of hardware startups that China can have versus Japan or versus India versus US. India is far behind there because of various reasons. And that is where how economy has evolved in India under various influences, all of this comes into play. But ground reality is that is where it is lacking currently. And that is where larger of the focus of India should be if India is to be a global leader. Because, if you see very fundamentally, the AI you develop a smartest algorithm, but the AI system that you are running, the hardware that you are running is coming off of China.
Correct.
I mean, how can you be confident about workings of the system, right? And this is not to blame. Yeah, this is not to blame China, by the way, but any nation for that matter.
Yes.
At national level, when one nation is leading at global level, there can be some foul play involved. Yeah, I mean that was history teaches us, and all this talk about geopolitics, etc. So it is a very fascinating aspect that how AI, like one of the leading researchers and angel investor out of China, Kai-Fu Lee, I believe, if I'm pronouncing his name correctly. He wrote a book. Yeah. He wrote a book on AI superpowers and China's role in it. Yeah. So, I mean, you would not have even thought about that book influencing where a technology is having influence on its political stability. Like, think about that. So that stability is deeply rooted into this building on this infrastructure. And that is where in my mind India is lacking. India is growing there. I can definitely say that. Of late, in the past couple of years, a lot of hardware startups have been growing up in India. Right. But there is some way to go because China is already far ahead in that aspect. Sure. So that's there. No, you were saying something.
Yeah, I think it's a great point what you raised about India, and the comparison cannot be done with respect to China because China is a closed system. We are scared about, the world is scared about what they're building, and they're so strong and they're publishing these reports every now and then. But I think if I come back to India, I really like your point that network is still not there, that resources are still not there. But I think on the hindsight, if we see the positive aspect of it is that we have a lot of push from the current government and from the previous ones about helping young people going into research and going into making their startups. And then this is just a beginning. I mean, probably in the next decade, we will see a lot of new young people going straight away into AI and AI research. So I think huge potential there.
Yeah. I mean, see, no doubt about India's potential. Like even at global scale, everyone realizes that what potential India possesses. I mean, see, any innovation that is happening in a country is a function of ingenuity and innovation that individuals themselves and in a group can do. And for that, all the globe is looks towards India. That India has the maximum amount of brain power. It is just that because of various conditioning, etc., to reach that fit where we can come out of the shackles. Indians can come out of the shackles and think about that they can build stuff which I mean, already there are stuff which is represented at global scale. But being as a leader, being the majority stakeholder in terms of building stuff, that is where potential definitely is there. But practically speaking from the point of view of timeline, if we trace it back from last 200 years, we are a little far behind. But yes, definitely the crazy potential is in front of our eyes. Yes, we lack certain things, but definitely we don't lack the brain power. Yeah.
And I think the advantage that we have compared to China is that we are more open towards, democracy in artificial intelligence or bringing new ideas to the country and then sharing new ideas with the world. For the last 2 decades, we have seen that our technologists, including you, myself, we have moved out of the country to find great jobs, to find new careers. And so I think that is where our advantage is, which China sort of lacks it because they are sort of stay in their own bubble kind, although they are doing a huge amount of work inside their bubble as well.
I just wanted to mention a few data points. For example, China has blocked Google access, right?
Right.
And that is why they have their own search engines, correct?
Right.
And various other services for that matter. Like WhatsApp is blocked. That is why they have WeChat. So what I'm trying to hint at is maybe the way something is functioning at a national level, it being again the double-edged sword that we're talking about.
Yeah.
So definitely there are demerits and a lot of bad things happen because of absence of, let's say, a particular form of government which is beneficial for most people. But then again, what many have argued is that because of such a system, such a closed system, the technologists of China were forced to build their own stuff. I'm not saying having a dictatorship rule that not to import anything from outside world. I'm not talking about that.
No, yeah.
But more talking about having policies in place such that the priority is given for homegrown solution. If that is to be the case, then people can, there are right forces around. Because think about this fact that if you are in China and let's say Google was not blocked and you have right set of skills to build your own search engine, which angel investor is going to give you money to beat Google? But if they know that Google is blocked in their demographic, they know that the people need a search engine, and here are a group of people who can build that search engine, the right set of conditions are met, then people are pouring in money to build that. So this is a very small and contrived example. I'm sure I'm missing out on many others, but the idea that there should be, so basically I'm trying to think about best of both worlds, where you have free market, where you can import stuff, etc. But you also have right set of policies at place where your homegrown solutions are prioritized. And by prioritize, I mean that actually right set of conditions are met. So the angel investor thing that I talked about, I mean, if there is a group of angel investors right now in India, let's say, who can pool in money to build their own search engine for that matter, because India has its own problem. We have 22 scheduled languages, not 1, 2, but 22 scheduled languages, and 22 are scheduled languages. There are many which are not scheduled. So, I mean, to, let's say, provide access to information, yes, we have Google, which is available in all the languages, but after doing, I mean, definitely Google has been making strides by releasing all these big NLP models in the later years. But just 5-6 years ago, the translation quality of Google Translate for Indian languages was not great for many of the languages, for example, Malayalam, etc. Because again, it is tackling those language problems apart from just English is a big challenge.
Yes.
So the point I'm trying to make is, if someone wants to build a search engine for all the languages which are supported in India, let's say, okay, and this is a homegrown Indian solution, do we have a network of investors which can fund that startup? Now, I mean, money is just one aspect I'm talking about, but many other layers are to be required there. Definitely, we need to have talent as well. So, like talent building for India. I mean, wherever they gain experience, but in some form of the other, they can contribute something back to India. So, those are some extra bits there.
Yes, fantastic. Great discussion we started with Japan, then China, then India, but great discussion. When it comes to self-driving cars, how does artificial intelligence creates different scenarios? Is it fed with a lot of data and then it acts by itself? Or is there any sort of intelligence carried out that human cognition has left behind compared to an AI controlling a car?
My exposure to the technologies behind self-driving car are, again, some of the projects that I worked some of my roles during my study at IIT Bombay, and definitely understanding of what is happening with Tesla.
Right.
I mean, the leading self-driving car arguably the leading self-driving car company in the world. I mean, Google might be making something in secret that is okay, but arguably the best out there right now. So when you say that different scenario, if we look at current understanding, the idea is that, let's say you are developing an AI system to detect obstruction on the road, and you make a case scenario that suddenly people could come out in the front of the car and the car should stop.
Yes.
And then maybe some animal could come out in the front. There could be maybe a bridge has collapsed in front of you and you need to stop. Some crazy cases. We need some samples of each of those scenarios so that we can show it to the AI system that we are training. Okay. Such that when we are deploying such AI system, it can detect such scenario and stop. But the idea is that, so when we plot this distribution, the distribution of all the various cases that can take place, having humans in the front, having the animals in the front, these are common cases, let's say. But the rare of the cases are a bridge collapsing in front of someone, some car, and the car stopping.
Or an earthquake came and then the road completely
Yeah,
is
yeah.
destroyed.
Yeah, sure, sure. So these are rare circumstances, let's say, but still the idea is that how folks at Tesla are trying to do is that trying to get the data set from this tail distribution. So these rare occurrences, and then trying to train their model with that data. And currently we're talking about the adoption of AI. Like I think no one has done it better than Tesla. So they first deployed their hardware infrastructure, which is their cars, these fast cars with which are electricity driven. So they had the infrastructure, and they aggressively started developing the AI aspects. So right now they have developed their own chip itself. Okay, I mean, they have developed their own chip as well, which is optimized for training their models. So the idea is that because they have, and also they have huge number of Tesla cars across the world. So all of those cars are collecting data of all the weird circumstances that can be seen on the road, that is being captured by Tesla, being fed to their own model, and being deployed as an update to the cars. So to answer this question of your different scenarios, when you say that AI creates a different scenario, that approach is taken only when we are in absence of that data. Meaning, even I would say that even when you have small sample of data, some form of AI is applied to create multiple such samples, such that you have enough samples to train your model. So let's say you cannot have multiple earthquakes to have, let's say, 1,000 samples. So let's say you have one sample of an earthquake happening in one part of the world on a road which affected roads on one part of the world. Now let's say you are trying to fine tune your software for USA or Europe or different countries in Europe. You're trying to fine tune that model, but you don't know how the earthquake would have affected the roads there. Let's say you are living in a hilly region. The earthquake happened in a planar region. Now you want to replicate that effect so that when you train your model, it can capture those effects if it is happening in that geographical landscape. So in that case, yes, I mean, there is the whole field of generating synthetic data where you try to, so it is like a style transfer thing. So when you transfer style of Picasso to your own painting, which looks normal, you can transfer the style of earthquake happening on roads from a planar region through how it would look on a hilly region. And then you can, with that data that you created, the scenario that you created, you can then feed it to the model. So it is part of how it is done, but at least you need one such case to be even able to train this, scenario, or in terms of, let's say, an image for simplicity's sake, to train your AI model. Because in absence of even that one sample, in absence of your understanding, let's say you don't have an understanding what a earthquake crack looks like. You can still argue that can observing how earthquake affected a standing wall, can I replicate the effects on a road? I'm not sure how effectively you can do, but given the fact that a wall, let's say the composition there is some stones and some, cement, etc., and on the road you have definitely a surface level different composition. There are stones, small stones, and there is, let's say, coal tar, etc. But the idea is that with some understanding of the physical property of both the wall and the road, you can try to, with a reasonable enough model, you can try to mimic the pattern onto the road. But let's say you don't even have an understanding of what the earthquake looks like. You are living in a place where earthquake has not happened for last 100 years. So you don't even have one sample to, think about the effect that an earthquake can have on a wall or on a road. So trying to build a model to even replicate, create different scenarios in such cases is a little tougher. But thankfully, so whatever is happening with respect to, in the context of at least self-driving cars, it is still a crazily challenging problem. But again, as I said, seeing the success rate of Tesla and the way they are doing it by modeling these tail distributions and even having synthetic data generation, all of these aspects covered. Yeah, that's how different scenarios can be captured. That's my view on this. Yeah.
Great point. I was actually also thinking that when we brought this topic of Tesla in this question, and also Elon Musk, is that Elon Musk usually comes and talk about the fact that AI is dangerous for us humans. I have warned you so many times. On the other side, he and his company is actually building something which is based on AI. I mean, the hardware is the same, which was there for over 100 years. It's a car, but it is now being run by a computer machine. So the point is, why are you building a thing that you contradict yourself? I have nothing against him. I love him as an entrepreneur. I love his ideas about SpaceX and everything. But he says that why did he say that when he's building it himself?
Right. Actually, it's a very good question. See, if we just see at surface level, people who either, let's say, 100% Elon Musk fan, they might become haters, or they won't.
They will dislike me. Yeah.
yeah. But the idea is this: that we need to take a step back and see the nature of the problem that we are trying to tackle.
Right.
So I think the idea behind Elon Musk's efforts toward Neuralink was only because of this fact that in his mind, he could not see outcome in which humans will overpower AI. AI is always going to win, the rate at which, let's say, we are trying to progress towards that. Now, the idea of, I think he said it in one of the interviews that with respect to AI, that if you cannot beat them, join them.
Yes.
And that is why this whole idea of having your own AI chip kind of a thing, interface to a AI chip into your brain, so that you are not a human, you are not an AI, you are a hybrid, so that you have some control there. Because in absence of that control, the idea is not about Elon Musk. How does anyone come up with a way in which you can think of an outcome in which AI is making some calls, and especially in the absence of the explainable frameworks, AI safety, alignment and everything, because that is still underway, right? We don't have a solution that AI decisions will be aligned to our own understanding.
Right.
So if not, how should we stop doing AI research? But the idea is that can it happen? Let's say as an ethical person, you think that maybe your invention will harm someone, so you stop inventing. But are you sure? So see, its idea is not about invention of that technology as a means of harm, but more so as a means of understanding. Why? Because if not, then if I'm not saying person here, but let's say if the people plus AI combination with a bad incentive is going to build that AI thing, how you as an ethical person are going to fight those things if you don't yourself have an understanding. So that is the broader understanding that I wanted to illuminate, that this idea technology is very tricky. Technology in itself is a double-edged sword. Even if you take let's say needle which is used to maybe stitch clothes, a person with right kind of knowledge can kill using that needle, right?
Yes.
Yeah, so that needle is a harmless thing used to stitch clothes, but that can be used to kill someone. So so should someone would not have created needles to facilitate their work to stitch clothes? So it is a very tricky subject actually, and but my understanding goes is that what we can put efforts towards is increasing the, I should say, awareness of human consciousness, so that the use of that needle or use of that technology is mostly ethical. Because again, Murphy's law, I mean, there will be definitely bad actors every now and then.
Right.
But the idea is that major chunk of the population, so that we don't wipe ourselves, we don't wipe the whole human civilization. The idea is that those, let's say there are points, I don't know how many percent which will be bad, but let's hope fair chunk of the population, not with AI I'm saying, with everything. Like take guns for example. People can kill guns, but there are laws at place in which, someone is doing it for self-defense. It needs to be fought in court, but people cannot, carry guns randomly on the streets and just based on some weird encounters, they start shooting. So the point is that this issue of whether something is useful or harmful has stayed with every technology that we have. It is just that we as humans have evolved using time and time there has come a point where we have evolved, and that evolution is definitely pending. Some say that, I mean, definitely Elon Musk thinks that it is with respect to having a hybrid form of human and AI, and that is a more plausible outcome that we can think of. But otherwise, we cannot argue, nor with AI, nor with any piece of tech, that this particular piece of technology is purely ethical. That's why let's do this. And in absence of that, don't do anything. Because I think we as humans, right from the time when we, ages ago, when we were, I don't know, naked, living in caves back in the day, when we started lighting fires to cook meals, etc. I mean, that was part of the tech. I mean, to provide warmth, etc. So, yeah, I mean, the point is that humans have always evolved to survive, to cooperate, to various other things, and always have found the next level of evolution with the help of these technologies that they see around. Yes, right now there are a lot of challenges, but I mean, as we are talking right now, we also are a species which are very hyper aware of the problem that we ourselves have created. I mean, yes, there are times when we are not, but I mean, collectively speaking, the larger challenges that we as on Earth level are facing, larger chunk of the population, they won't say that, oh, this is bullshit, this is not happening. I mean, they know that, for example, climate crisis is real, and they understand its implications. So everyone understands it. So the point is that we are hyper aware of the problem. So once one as a group, as a society, we are hyper aware of problems that our society faces. As you know, moral beings acting in the society, we work towards the solution, and that is what. And the solution could look different to others, but that is the goal. That is how humans have evolved with different technology. AI to me is no different, and that is where we are going. Yeah.
How do you design a universe in artificial intelligence? I'm trying to take you to simulation, because if we can simulate the universe using AI, then do you believe that somebody, a higher cognitive power than us, might have already created it as our universe and we are part of a simulation?
So physics started as us humans trying to inquire the laws, trying to uncover the laws that are acting in the nature.
Right.
And we, tried to come up with, there is a Big Bang theory and how basically universe came to be. And some of those theories do explain to a decent extent, but we are yet to have some grand, unifying theory in physics which can explain most of the physical phenomena that we are able to observe. Now, the idea that I like about when you say this, whether an AI can simulate a universe or not. So the idea is that, see, nature, so to me, nature is working in a way, we are, through our interaction with nature, either through our experiments or experiences or whatever, we are trying to build our theories. It could be that when we are trying to come up with a mathematics to explain that phenomena, it is only because our minds are capable to explain a certain kind of pattern only. That is why we are able to only observe and experiment and mathematically formulate that aspect of the nature. But there is a larger aspect of the nature which is still uncovered to us. We don't know that. We cannot comment on that. Now the question comes that if an AI is supposed to do that, the idea is that whatever humans can uncover, the AI can, in that realm, in that pattern realm, can learn to predict those kind of patterns or observe those kinds of pattern in nature. But if a discovery is to be done for, let's say, new laws or maybe some unified laws of physics, I mean, there are definitely researchers working on this as well, like physics department and AI department working together, physics trying to inform physical concepts, maybe trying to bring into building new models and using AI to discover new laws. There have been some work, but those are at very primitive stage. So there, I believe I'm aware of one such work to predict some structures in the cosmic observation that we do of space. But again, those structures, we can argue that, and it has been shown that the neural models can predict those structures with a decent accuracy. But again, the question comes that whenever a new, so now see, let's try and understand that we understand if let's say the AI model is predicting that such and such structure exists in your cosmic universe that you are a part of. My point is that how do you as humans accept that conclusion of that AI system? And that is where the having that module of, again, I will go back to the same things of having some interface through which you can trust these AI models. And
Right.
think about that, how even you can build such a system to trust, such explanations to trust. Because you yourself as humans acting in this universe need to understand that structure, right? And for you to understand, yes, AI can help there, but again, to simulate it fully, to me, it is a lofty goal. I mean, we, until unless we as humans don't understand it to a certain extent, whatever the AI will predict, we cannot accept, right? AI can predict all sorts of things. How do we
Correct.
guarantee that whatever the AI has simulated is the correct simulation? So yeah, I mean,
Right.
people are working for simulating some physics laws, but those physics law has already been observed and discovered in physics. So let's say there are simulations happening for effect of gravity in, let's say, games that we play on our computer, which are very realistic. But these laws are again discovered by physicists. So we have an understanding of gravity, but in the absence of some laws which we don't have an understanding of, how do
Right.
we how do we go about doing it? So yeah, that's where this conundrum is there, that even if an AI is able to simulate it, how do we ensure that the simulation is what is the closest to the reality that we live in? Yeah.
Correct. That makes sense. Yes. Fantastic. Great answer, Prashant. And I think I have exhausted all my questions. So this is where we end. What is your opinion of the podcast, and did you enjoy it or?
My pleasure, Vivek. So thank you so much for inviting me to this wonderful podcast. I mean, kudos to your efforts in this direction. So, I mean, I really enjoyed the opportunity that you gave me, and I hope I could add some value to your podcast. So, yeah, but I had a lot of fun as well. So, thank you so much.
Fantastic. Absolutely. You've added a lot of great value to us. And depending on your schedule, we can probably go for a second round sometime in the future. Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.